Question 8 is a chi-square test, and as such we're asked to state the null and alternative hypothesis. So the null hypothesis is always that the two things are independent of each other. So in this case, age and I guess opinion on reduction or opinion on minimum voting age are independent. Or independent. Okay, always use the word independent. And the alternative hypothesis, you copy this exactly the same as before, age and opinion on vote reduction, however you want to phrase it. I don't mind that part. This part is important, are dependent. Okay, they depend on each other. So we're going to assume that these things are independent unless we can find some evidence to suggest otherwise. Question 2 says write down, or part B rather, says write down the number of degrees of freedom. So we talked about the degrees of freedom being how many, what's the minimum number of these boxes that you'd need to know in order to fill out the rest of the table. So if this is fixed because it's total numbers of people, this is fixed, this is fixed, this is fixed, this is fixed. If I told you this, you wouldn't need to know this in order to calculate the total. So you'd need that one. You'd need some more information, so you'd need this one. And then I could find out that one because this plus this makes that, so I wouldn't need that. And if I knew that and I knew that and that, add that makes 80, then I wouldn't need this. And if I knew that and I knew that, then I could figure this out as well because this plus this plus this makes that. So the number of degrees of freedom here is 2. The formula we wrote down for the number of degrees of freedom was the number of rows minus 1 times the number of columns minus 1. So in this case, the number of rows is just 2. So this doesn't include the total. Okay, so the number of rows would be this one and this one. 2, the number of columns would be this one, and this one, 3. So rows minus 1 is 1, times column minus 1 is 2, and 1 times 2 is 2. You can also do that on your calculator. We'll have a look at that when we come on to part D and part E. Show that the expected frequency of those aged between 26 and 40 who oppose a reduction is 21.5. Okay, so let's have a look. People between 26 and 40, we've got 35 of those, and people who oppose the reduction, we've got 80. So, if these two things were independent, we'd expect of the people that oppose the reduction, so that's 80 out of 130, this total down here, we'd expect this proportion of people aged between 26 and 40 to oppose the reduction as well. So we want this proportion of people aged 26 to 40. Well, how can I find the total people aged 26 to 40? That's 35. So I want this fraction of the 35 people to oppose the reduction. That's what I would expect to happen if these two things were independent. Okay. Now the way we looked at that, or the shortcut formula, if you like, we talked about was to do row total times column total over total. Okay, so what I mean by that is here's the column, so here's the column total, so 35. Row total, for those who remember, we're looking for oppose. Row total was 80, so 35 times 80 divided by the total divided by 130. This and this are the same thing. Okay, this is the same as this. And if you'd done that on a calculator, it of course would have come out to 21.5. So you needed to show this working out in order to get the 2 marks there. In part D, you're asked to find the chi-squared statistic and the p-value for the test. So both of these things can be done on a calculator. So let's just go through that now. On a calculator, you're going to enter it into a matrix. So you have to go to matrix and vector, create, and we want to create a matrix. And number of rows was, if we look at this, we don't include the total. So it's just 2 rows and then 1, 2, 3 columns. 2 rows, 3 columns, and just enter the data that was in the table to start with. 48, 17, 15, 18. Okay, now I want to store this, oops, lost it. I want to store this matrix in the calculator, so I'm going to say store, just above var here, and I'm going to give it a letter, so I'm going to say store it in N. Okay, and press enter. Now whenever I press N from now on, it will remember that the letter N is that matrix. So now I want to do a chi-squared test on the letter N. So it's menu, statistics, stats test, and a chi-squared two-way test. Where observe matrix, so we just called it N, so observe matrix N, okay, and there you go, it's done the chi-squared test for you. So a few different numbers to look at here. Firstly, DF stands for degrees of freedom, so I think it was part B that asked you for degrees of freedom. You can just do it using the calculator. This x squared is actually chi, so chi squared is 10.32, or 10 to three significant figures would be 10.3, and the p-value to three significant figures, remember the zeros aren't significant until after the first number that's not zero, so 0.00572, but the 5 will round the 2 up to a 3, so 573. So I'm going to go back and make a note of both of those values. So chi squared 10.3 and p-value 0.00573. Okay, now it says give a reason whether you would accept, given a reason whether you're going to accept H0. So this is where a lot of people again were getting confused. The way we talked about it in class was we said, imagine I did a chi-squared test hundreds and hundreds and hundreds of times and I got a distribution of chi-squared values, and it looks something like this, depending on the number of degrees of freedom. So this is the frequency, this is how often it comes up, this is the chi-squared value. So on here, when we're testing, I've just cropped this from the question, it said that the chi-squared critical value is 9.2. So was it 9.21? So there's going to be a cut-off point here, which is a chi-squared value of 9.21. Now if we're testing at the 1% significant level, that means that 99% of chi-squared values would fall below that line and 1% of chi-squared values would fall above it. So if we're going to accept H0, this idea that they're independent, then our chi-squared value must come up on the left-hand side of this critical value. So our chi-squared value is 10.3. So that is going to put us in this region over here. Okay, now remember I said that region, we only expect a number greater than 9.2 1% of the time, so it's very, very, very unlikely that these two things are independent. It doesn't look like they come from this distribution. So if your chi-squared value is greater than the critical value, then we reject H0 and we accept the alternative hypothesis. So we reject the idea that they're independent and accept that they are dependent on each other at the 1% significance level. Okay. Now that's not to be confused with, so that's fine, you'd get full marks for that. But it's not to be confused with the p-value, because that's compared to the significance level. So 1% significance level, our p-value as a percentage would be 0.573%. Okay, so because this p-value is less than the significance level, again, this suggests that these two things are dependent on each other. Okay, anything less than the p-value means this is very, very, very unlikely to come up. So in the case of the p-value and the significance level, it's the other way around. So because my p-value is less than the significance level, then I come to the same conclusion. I will reject H0 and accept the alternative hypothesis. Now, you don't have to put both of these things, okay? You choose. Either you compare the chi-squared with the critical value given, or you compare the p-value with the significance level. You don't need to do both, but either way, if you interpret them correctly, you should come to the same conclusion, which is that you reject the null hypothesis in this circumstance.